So the next thing to talk about is called the mean or the expected value of the random variable. So if capital X is our discrete random variable for some experiment, then the expected value, sometimes this is written as mu for the mean, but the mean or the expected value has the following formula. So it turns out what we're going to do is we're going to add up all of the values little x times the corresponding probability that our random variable takes on that value little x, and we add this up over all the possibilities for a discrete random variable. Since it's a discrete random variable, we can add all these up no problem, since we can list all of them. There's some finite set of values here. So that's going to be our expected value. So as a first example, let's go back and let's think about, I'm going to just go back and use our coin in our dice example. So here we flipped a coin. So we flipped a fair coin 3 times. And we found the following probability distribution. So to get the expected value, what we're going to do is we're going to take and we're going to multiply the outcomes, the possibilities, the outputs of our random variable, the possibilities of what our random variable can be, times the corresponding probabilities. And then this symbol means that we're going to add them all up. So we're going to get 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. So again, all we're doing is we're multiplying these. So multiplying and then adding all of those up. That's going to be our expected value for the discrete random variable. In our case, what's going to happen is we're going to get, well, 0/8 is 0, 3/8 plus 6/8. So 3/8 plus 6/8 plus 3/8. So that's going to be 12/8 or 1.5. So the way that we interpret this is that what this says is that if we were to flip a coin 3 times, and if we were to do that, if we were to do this experiment, say 1,000,000 times, we would expect on average to get 1.5 heads. Remember that our random variable x counts the number of heads. So capital X counts the number of heads that are flipped. So we would expect on average we get 1.5 heads. Notice that it's never possible to get 1.5 heads when we flip a coin, right? We can't get half a head here. So all it's saying is that on average, we would expect roughly to get 1.5 heads on average. So if we were to do this 1,000,000 times and write down how many heads we get each time, the average of those values should be close to 1.5. And it doesn't matter that 1.5 is never possible. 1.5 is not a value that our random variable can output. That's okay. This is just a statement that on average we'll get 1.5 heads. And let's do the same thing for the coin, or for the dice experiment that we had before. So we roll 2 dice. Capital X counts what we roll. And we found the following probability distribution. I'm just going to steal it here. So we found the probability distribution. Let's try and move that, make that a little more legible. Oops. Okay. And so it turns out that our random variable is going to have expected value equal to, we'll have 2 times 1/36 plus 3 times 2/36 plus 4 times 3/36, and so on. I will write this all out. 5 times 4/36, 6 times 5/36, 7 times 6/36, 8 times 5/36, 9 times 4/36, 10 times 3, almost done, 11 times 2/36, and 12 times 1/36. And it turns out when you add all of these values up, what you get is 7. It works out to be exactly 7. And I'll let you check that on your own if you'd like. It's a pretty easy calculation. But it turns out that the expected value is 7. And so what that tells you is that on average, if you were to roll 2 dice, say 1,000,000 times, and then write down what you get, there's a very good chance that your average of doing this experiment 1,000,000 times will get you close to 7. So on average, you should get close to 7. And that makes good intuitive sense if we think about rolling 2 dice graphically. So if we think about this as, well, that makes good sense because this is symmetric and the value with the highest probability is 7, of course, but also this is just as likely to be less than 7 as it is to be more than 7. So on average, it'll balance out and give you about 7.